Okay, this is a series of YouTubes I'm making to show a walkthrough of solving certain programming problems. I'm using Python, and we're going to look at rock, paper, scissors. This is an early assignment I used to do in my classes after learning Python. So we're going to walk through how to develop a solution, and then we're going to look at different approaches to solving the same problem, and we're also going to, as we go, learn about simplifying your code or changing it to work better, which is called refactoring your code. So we're going to take the rock, paper, scissors. If you're not familiar with rock, paper, scissors, two people present either rock or paper or scissors, and then depending on who chose what, rock will beat scissors, scissors will beat paper, and paper will beat rock. So let me run it so you can see. So I have a lot of different solutions I'm going to go through, but let's start with the basic one. Okay, so when we run it, it uses the console programming, so it's going to interact to the terminal here, and on a PC that would be either PowerShell or the command prompt. So it gives you a prompt, which we call that in programming. So the program outputs this prompt, and I'm just going to type a single letter to pick whether I want rock, paper, or scissors. Notice I can use upper or lowercase, and then I'm going to hit a Q if I want to quit the program. So if I hit Q and hit enter, it quits the program. I'm going to run it again. If I to paper, it plays, the computer picks rock, so the computer randomly picks one of three choices at the same time, quote, as I pick it, and in this case I win against the computer. If I hit paper again, the computer also picks rock again, but if I hit P and the computer picks paper, it says you tie against the computer. So the program picks up what the user picked, it picks a random choice for the computer, and then it puts a statement that says you tie against the computer, you win against the computer, or you lose against the computer. And if I type Q and hit enter, it quits the program. So that's basically it. Let's look at some things here. So a sample run, we want to output this prompt. So here's the prompt here. This is the templates we're going to work with. And then the user does some input, so I showed what the user inputted here, but they can input any of these choices. We're not writing the program to handle bad input, just to simplify things, so don't worry if they type something outside of this. It will probably just bomb your program. That's fine. Then it prints out what the computer picked as a full word, and then it says you tie or win or lose against the computer. So the template just shows that this result here is the only thing that changes in this output, is what the result is. And so the computer pick is either a computer, paper, or scissors in this template on the output. And in this output, the only thing that changes is result, which is either tie, win, or lose. And that's it. So a classic approach after you've learned if statements is, of course, to do this all with if statements. So some things you're going to have to do is convert the user input into lowercase so that it accepts both upper and lowercase. We need an if statement for the user choice with 3 if statements inside for what the computer picked. So that shows the structure. So if the computer picked R, you're going to have an if to decide that, and inside of this we'd put 3 ifs for what the computer picked, and depending on those 3 ifs we would have what we output. And we'll show this in code in a minute. We also want to have a loop around this whole, so we run over and over. So in the loop we're going to loop until the user is not, as long as the user has not picked a Q. So basically this if statement, getting the user, and this if statement, and we'll be in a loop. So let's actually look at the code for this. So this is the first version. And this code's all available through GitHub. So let me show you where that is. So if you go to github.com/jerry-jenkins-lb/walkthroughs/tree/python/rps_solutions. Now that's a long thing to type, so if you look at the description of the video, it'll be in the description. You can go directly to this link. So by the way, I'm using an editor called TextMate here. I normally do things in PyCharm for Python, but TextMate's also a really good editor, or Visual Code is a good editor. So there's a lot of editors you can use for Python. This version is most basic. It's got a lot of redundancy in it. So we have to import random in order to pick a random number or from a random list. This is the prompt we're going to output. So I put it as one string with new line characters to output the whole prompt. So here's our loop. So I say while true. This is a trick to do an infinite loop, and then you just detect when the user types a Q, exit the program. So we do a break statement to get out of the loop. So this is where we get the user input. We get the input, and then we ask that string that's returned to be changed to lowercase before it's stored in the user. So user now has the input. Computer is going to be what the computer picked, and the computer picks a string from this list of rock, paper, or scissors. So random.choice, you can pass any list and it'll pick a random thing out of that list. It's going to print the first output, so it's going to just print computer picked and then print out the string the computer picked. So here's our nested if statement. So if the user picks rock, then we have the cases where the computer picks rock, that's a tie. If the computer picked paper, that's you lose against the computer. And if the computer picks scissors, you win against the computer. So basically that structure we saw back here, we're just implementing these three if statements cases. So there's a total of, there's a lot of if statements. So you can see here's the next user case picks paper and the three outcomes for what the computer did. If the computer picks scissors and the three outcomes there. And that's the whole program. This loops, it gets user input again, and it only exits the loop when the user types a Q. Now as I said, this is very redundant, so what we want to do is a lot of things we're doing over and over again. Instead of outputting this whole string, let's just pick the tie, the win, or the lose. So because they're basically the same. And so we're going to, and also the ties, we don't have to do all these ifs for ties. Ties, if the computer and the user pick the same thing, we can say they tied. So we can pull that outside of this if statement. Now the second one of these does that, and what we're doing here by simplifying all this is called refactoring. So the things we all just talked about to simplify the code is called refactoring. So we're going to see a similar structure, but you'll see it's a lot simpler. So you'll see we've first we pulled out a template string, which is our output. So this is a placeholder that's going to be replaced with the win, tie, or lose string. We'll see that later. We have our loop. The user input's the same. Checking if quitting is the same. We're going to now set the result before we start to lose. This is a technique to get rid of half of your ifs or elses. So this is going to be a default. If we don't choose an if for anything else, we're going to choose lose. You'll see that happens when how that works later. We're going to do the same computer choice. We're going to print out what the computer chose. Now what we've done is we pulled out the tie situation. All we have to do is check that the first letter of the computer, which is rock, paper, scissors, is the same as the user. So if they're the same, we set the result to tie, and we're done. So we're going to jump down to this printout. If it's not a tie, we have three ifs. So if the user picks rock and the computer picks scissor, we've detected a win. So basically these three ifs detect a win. So the user picks rock and the computer picks scissors is a win. Paper, rock is a win. Scissors, paper is a win. If it's not a win, we have our default still set, which is lose. So when we get down here, the result will be one of those three strings. We format the template, so this format method on strings will plug this into this template here. Now just note, we can also get rid of all three of these ifs if we make a really long Boolean expression. If we take this Boolean expression here and we add or, and then we put this Boolean expression in, and then we add, and we're going to put that on 2 lines. So let me do or start a new line, and then we're going to take this expression and OR it with this expression, or start a new line. So now we have an if statement that has a very long Boolean expression. So this is the three conditions, three ways that the user can win against the computer. So that's why we have OR. So if any one of these three are doing that, we set the result to win. So that's another way of simplifying things. So when you work with complex ifs, look at things you can pull out to make it simpler. So now we might not want to do this just because the three ifs may be easier for you to look at later and figure out what you were doing. When you have complex expressions, especially Boolean expressions, without any comments, it might be tricky to figure out, well, what was I doing here when you come and look at this program a year from now. So that's why my preference is to keep it the way it was originally with the three if statements. So that's that. So let's look at the next approach is using what's called a lookup. So a lookup approach was going to be a different way of solving the problem, and this is called refactoring as well. So in this thing, we're going to look, well, the user picks rock, paper, scissors, and the computer picks rock, paper, scissors. Let's put that into some kind of key, which we'll show you how to do, and then look that up in a dictionary and return the string win, lose, or tie. So let's look at how that works. So this is the lookup one here. So the lookup one, we create this dictionary that has the letter the user picked, and rock, paper, scissors is one character the computer picked. So basically we pass in for the key the user and computer choice as a string, and it looks up the string rock, tie, lose, or win. So this one dictionary replaces all our if statements. So we basically have full names. So this is another lookup which looks up the computer choice of one character and gives us the full name. We'll see, we'll use that when we do output. So we have the same kind of loop. We get the same kind of input. We have the same if the user picks a queue, quit. But here, the random choice, instead of choosing from a list of strings, we're choosing single letters out of a string. So choice will also do this because you can pass it any sequence and it'll randomly pick from that sequence. And a string's considered a sequence. So now we say what the computer picked. Well, we have to look up the full name of what the computer picked from that single character. So that's what that full names was for. And then we print U. And we look up in the rules win, lose, or tie by looking up the key of the user character concatenated with plus to the computer character. And so that's going to look up and return win, lose, or tie from this rules up here, and then against the computer. So that prints our second output. And so that's the whole thing. We've really simplified things. Just to show you a third approach is this pattern RPS. So the pattern RPS is going to look very similar, but what we have here is we have a string which has the patterns that win. Because this is really that original slide. This is the patterns, rock beats scissors, beats paper, beats rock. So this kind of incorporates that as an idea. Look for this pattern of a win and just detect the wins. So let's see how that works. So once we got the user input and we've checked if we're going to quit, we pick the computer choice. We're going to print out what the computer picked. And now we're going to take the computer pick's first character and convert it to a lowercase and store it in the computer character. And we have a template. In this case, we're using the Python 2.7 original templating, which uses what's called printf syntax. So this fs is a template string, but it uses %s as where it's going to plug in the result of our template. So here we're concatenating the user character and the computer character into one string. And if this is in win, so n will search for this sequence of characters in the bigger string wins. So wins, if it finds one of the winning combinations, then it's going to print this one. So it's going to print fs, and it's going to substitute the string wins in for the %s. This is the old modulus string operation to plug in parameters into a string. Else, if the user equals the computer character, we have a tie, and then the else case we lose. So that's the complete solution. So we hope you've enjoyed these walkthroughs to show you think about different approaches when you solve a problem. If your code looks redundant, look at refactoring it to make it simpler. And if you find a better solution, maybe using a dictionary, it might be a simpler solution. Also try different kinds of solutions to simplify your code.